The CDX Exchange Builder from PDSG. The CDX Exchange Builder is a registry and repository-driven set of information exchange design and development tools. It employs an ISO standards-based metadata XML registry and uses a pure XML architecture that relies on XPath and XQuery to link logical business objects from the canonical model to any of the current XML domain vocabularies, such as GJXDM, LEXS, and NIEM. CDX Exchange Builder walks the developer through a best practices process of requirements definition by first focusing on business needs and rules, then defining the data payload, the technologies for implementing the design exchange, and lastly, the rules and policies for secure and authorized sharing of the exchanged data. The modeling features of the Exchange Builder captures and isolates each of the exchange design perspectives, the business model, logical model, and physical model of each exchange, and separately renders the IEPD components, or runtime artifacts, from those reusable and sustainable business models. Exchange Builder was deployed on a pure XML architecture called XRX. Native XML databases provide access to components of the canonical data model within the metadata registry and user-controlled project repository. All elements and components are composed from canonical XML registry objects, which makes these tools highly efficient and reusable. When applied to the conventional methodology for NIEM IEPD development, CDX Exchange Builder becomes the processing hub. From defining the exchange to gathering the business rules model and the required data payload structure, the Exchange Builder then automates the difficult process of transforming information exchange business requirements into XML domain conformance standards and IEPD artifact generation. When used with CDX runtime products, developers can test and deploy these exchanges in real time, allowing your enterprise to use an agile approach to iterate through one project after another, testing and deploying as you go. The semantic foundation for data transformation is the metadata. Each enterprise data sharing project should begin with a universal collection of semantic metadata that commonly defines all things in the enterprise. Exchange Builder provides this foundation. CDX is specifically designed for use in the justice, public safety, and criminal intelligence communities. A semantic metadata registry ensures that all new development projects are using the same components and definitions based on a reusable canonical XML model. The CDX metadata registry is based on the ISO standards, as was the GJXDM and NIEM naming conventions, and the canonical model provided can be augmented and localized for each enterprise within their own repository. The registry allows for consistent use and reuse of common domain artifacts. The ability to connect and federate registries and repositories allows for an enterprise-wide adherence to SOA governance principles. Let's look at the metadata registry. In principle, it contains a canonical model of all the logical structures and definitions for all persons, things, and activities described in justice information exchanges, including the domain-specific roles such as suspects, victims, and witnesses. Further, it maintains the inheritance and relationships that are possible or dependent between these entities and their roles. Separately, CDX Exchange Builder maintains relationship mappings to the equivalent elements and structures of the most common standards vocabularies, such as NIEM, LEXS, JRA, and GFIPM. The enterprise mission of managing SOA governance begins with the enterprise semantic metadata. The enterprise can manage definitions, add locally defined components to the canonical data model, and make the entire collection available to all constituents as common building blocks for projects across the enterprise. Using only an exchange vocabulary, such as NIEM, does not provide the lifecycle perspective required for SOA governance. Exchange Builder and its metadata registry provide the lexicon of logical objects and definitions for all perspectives in the enterprise, and they can be managed over time with an SOA governance model. Let's take a closer look at how the metadata is used. In the metadata registry, we see the full collection of atomic building blocks. In development, we can illustrate how this common enterprise collection of metadata objects can be selected through the business-driven requirements and emerging business needs to define and deploy new business artifacts, such as Exchange documents, forms, reports, or even newly integrated enterprise applications and web services. From an atomic view, everything needed for defining and deploying an enterprise exchange or service is defined by increasingly complex structures, each built from the essential metadata objects. All are derived from combinations of atomic registry components. And for lifecycle management, each can be defined and tracked back to their source registry objects. Let's look at an example of defining a warrant document for Exchange. In principle, the business needs will define what data objects are required for the exchange, the components that define the warrant object. In ExchangeBuilder, this is done at the logical level using canonical metadata. Next, when defining the physical representation of this new exchange model, the user chooses the current vocabulary they wish to employ for the physical exchange. For instance, a developer might choose the most recent version of NIEM. ExchangeBuilder automates the physical generation of IEPD artifacts, seamlessly connecting to the NIEM schema generation tools and returning the physical artifacts required for a conformant NIEM IEPD for this warrant exchange. Project components, as defined, are stored as XML collections in the metadata repository, where they can be tested, deployed, and managed over time across the enterprise. The metadata foundation of the ExchangeBuilder allows for full lifecycle management of Exchange artifacts, both in design and runtime. As the hub for all enterprise development, ExchangeBuilder becomes the fundamental resource for SOA governance, managing all artifacts defined and deployed across the enterprise. After exchanges are put into production, quality of service and service-level agreement policies can be managed and monitored. ExchangeBuilder works in concert with the CDX runtime products to provide the physical implementation definitions of partners, endpoints, security policies, and exchange protocols. From a compositional point of view, using the CDX ExchangeBuilder and its metadata registry ensures that all Exchange components are being defined and used consistently across all Exchange projects and new services as industry standard and deployable SOA components. The importance of SOA governance becomes evident as an enterprise begins to deploy dozens and dozens of new services. In the absence of an approach grounded in an SOA governance model, many developers have stumbled upon a well-known phenomenon known as Bose effect. Over time, they realize they have merely created a bunch of web services with no consistent definitions, structures, or systematic means for running dependency tracking and providing maintenance. With ExchangeBuilder, however, all services and service components are built from registry objects, and all projects and services can be managed with ExchangeBuilder. Through SOA governance, when an object changes over time, dependency tracking can be executed by tracing all instances where any object or element has been deployed within the enterprise. Whether using conventional Exchange IEPDs or developing JRA-based service packages, the ExchangeBuilder output is a consistent collection of artifacts, each defined in common metadata, and each profiled using the best practices of the global justice standards and specifications. CDX ExchangeBuilder provides an easy-to-use development environment, and through the use of metadata service registry, it fully delivers consistency, reusability, and full lifecycle management, including dependency tracking for instances where justice standards and best practices change or evolve over time.